Welcome to our webinar today, Building a Better Future, an introduction to Passivhaus and future-focused builders. So this is especially designed for builders and thinking a little bit different about Passivhaus and how to approach it. And it is still beneficial for designers and for homeowners or future homeowners. So definitely there is a benefit for everybody as I'm going into the principles of Passivhaus, but I'm as well talking a bit more to the builders today because they're putting our dreams into reality. And that's what I want to talk about. And they may even play a bigger role in the future regarding the building industry. And that's what I want to talk about as well a little bit. Okay, so let's start. For the people that don't know me, I'm Daniel. I started my career as a carpenter back in Germany, and I was straight away focusing on eco homes. And yeah, I really fast realized that eco is not sustainable, and that's happening in Ireland when I was actually starting to import prefabricated houses from Germany to Ireland. And I realized, wait a second, eco doesn't mean sustainable. For example, if you would use only cork insulation, where we have a 7-year harvesting cycle for a cork tree, then that wouldn't be sustainable because that material is not produced fast enough if everybody would be using it. Yeah, but then I really fast realized as well, sustainable doesn't necessarily mean healthy, because we can now be really sustainable, but have a lot of mold problems and toxins in the house. And that's when I realized I have to bring everything together. I need to think about the ecology, about the sustainability and health. And that's where Passivhaus came into my world really big. That took me 10 years to get there, from the start of my career to actually saying Passivhaus is good. I actually was against Passivhaus for my first 10 years because I didn't want to rely on a ventilator to survive in a house. Like, you may have been having the same situation, or you're going through the same process, so totally get it. It took me as well a while. Then after Ireland, I went back to Germany and I did my bachelor and master's degree in Germany on civil engineering, structural engineering, but really strongly focusing on building physics and building chemistry, how that all works and how that impacts us. And then I went to Canada, did my master degree as well in Canada, where I again went on structural and building science, bringing it all together. And then I actually applied all that in the EU as a researcher for the European Union on energy efficient building knowledge transfer between the different regions of the EU and how we can actually do that across the borders. So that was super interesting. We had a conference running as well with 3 different languages and working with the dolmetschers and content and presenters. It was, the thing I've done before. And then I obviously came to Australia and starting to work in Australia as well, prefabrication and then education, because education is the part that I can have the biggest impact, I believe. So the changing industry landscape is what I want to talk about a little bit before we start. We have increased challenges, like we have more frequent heat waves, we have more bushfires and storms, building and greater buildings need to be more resilient, especially against heat waves when there's a power grid failure. And the reason for that is that heat waves are the most deadliest weather event that we know of, especially during a power failure. We can have that problem. When was that? Was last summer, I think. There was this article in Australia where this resident was measuring, I think, 43 degrees in their apartment, and they had no cooling system. That's super, super dangerous. In 2023, we had nearly 70,000 people dying in the EU because of a 2 weeks heat wave. And that's coming more and more often as we have these changes happening. Effective solutions are needed. We need better insulation, we need better air tightness and independent cooling system. And that is all what we have in the Passivhaus principles. I don't know if you have seen the posts all over social media regarding this special house that survived the LA bushfires. That was a Passivhaus. Passivhaus didn't necessarily make that survive. However, you see that quality building makes a difference. And if you're thinking about how you're actually executing a building, then you can have these benefits. And everything else is burned down except this building in that state. So there you see that there can be a big difference. And yeah, something I wanted to point out. Then electrification of everything is happening. We have a rising demand on our grid that is coming from them. So our buildings going to electrification, transportation system, all the electric cars, the industry is going there, even like steel plants are going electrical now, and we are moving away from gas and liquid fuels. And this is so this is putting a lot of stress onto our electrical system, our electrical grid, and that is what we have to consider as well in our design, because the skyrocketing demand that we are seeing, are mainly domestic. And we can change that by applying the Passivhaus principles. We can reduce the pressure on the grid, and we can help to make the grid more cost effective with our design. So that is not necessarily a benefit to the builder, and it's not necessarily a benefit to the client, the end user, but the society would actually benefit from that. And that's something that actually governance and decision makers need to consider in moving forward. Here, an example from Greenland that's already a few years old, but it shows exactly what's the problem. Residential demand is responsible for 43% of the peak demand, and 13% of the electrical network is used for less than 1% of the time when we have these extreme weather events. Why is that happening? Because over 3,000 air conditioning units were installed per week in 2010. And in Queensland, they had this massive investment into the electrical network, and that is 15.6 billion. And that's as well explaining why 49% of the cost is actually network costs. Considering this, that everything needs to go now through these copper cables. So everything that we're putting into our tank, that is gas, that is liquid fuel, needs to go through the copper cable. So we need to expand this grid massively. However, if we now creating even higher peaks necessary, that will start to be really, really uneconomical. And that's what we can address as well with the Passivhaus design. Then bushfire smoke and indoor air quality. I guess we all remember 2019, where pretty much everywhere was smoke. With Passivhaus, we're having an airtight building and mechanical ventilation. And by this, we are able to filter the smoke out of the air and having a better indoor air quality. For me, it was really bad in 2019 because the smoke was just coming in, and I was trying to record videos and stuff, and I got asthma, itchy eyes, and running and everything. So it was pretty bad. We can avoid that by living in a Passivhaus. Unfortunately, I'm not living in a Passivhaus yet, but hopefully soon that will be happening. So now let us look into Passivhaus principles and the benefits. So first of all, we hear it all the time. There's thermal insulation. So Passivhaus puts a nice woolly jumper around our houses at the end, and is making the house protected against the thermal difference from the outside. So this thermal insulation is not caring if it's hot outside or if it's cold outside. It stops the energy flow. So it doesn't know, the thermal insulation doesn't know where inside and outside is. It just stops that energy flow. And by that, we have a far better performing house. Then Passivhaus windows. These are just windows that are designed for your climate and your location, that you don't have too much energy coming in. It's a myth that they always have to be triple glazed. They don't have to. Often in Australia in particular, we are getting away with double glazing because we're having such a mild climate, and double glazing is good enough. Then thermal bridge-free design. That's where we are making sure that nothing is getting cold, and that the corners are getting cold, because a cold spot is a mold spot, and we want to avoid mold in our building because of the health reasons. Thermal bridge-free design is for me far more a health requirement than actually an energy efficiency requirement, and that's often misunderstood as well. And then we have our air tightness, and that's like putting over our woolly jumper windbreaker, and by that we can have the biggest wind outside, but the thermal insulation is still working. Our thermal woolly jumper is as well working when we are out in the wind. And that's what the air tightness is actually doing. It helps us to get the thermal insulation to perform. That's pretty much what it is helping us. Otherwise, we have wind washing, and the wind washing is then reducing the performance. As we are now creating pretty much a closed box, we need to have our heat recovery ventilation unit that is ventilating the house and making sure that we're having fresh air in the house. Unfortunately, natural forces are not reliable. So just opening a window or having holes in your wall to have fresh air coming in is not sufficient, because the pressure difference between inside and outside is always changing. For example, these days we're having in Paris over 30 degrees in the middle of the night, but even if you open your windows, no air is moving at all, and you're just melting away if you're not having a cooling system. So this idea of natural ventilation using natural forces doesn't work. That's the reason we need a mechanical force to actually move the air around, and that's what our HRV is, our heat recovery ventilation unit. If you're ventilating with mechanical force, then it makes sense as well to recover the heat so that the outside temperature is not coming in to the building when we are ventilating. So at the end, it just keeps the indoor temperature indoors and the outdoor temperature outdoors. So when we are now looking to how much energy we can save on the heating, the cooling, the domestic hot water, then we're actually able to save 75% compared to a low energy building. If we're comparing it to a traditional construction, then it can be savings of over 90%. And that's what Passivhaus is giving us for a little upfront investment. So what are the benefits to the client? We have this consistent indoor temperature and indoor environment. We have the indoor air quality as well during bushfire and heat waves. And then we have this cost savings, reduced energy bills, and cooling possibility possible with solar energy production on site. So I think we should always design a building in a way that we can cool the building with energy produced on site, because if there's a power failure, then we can still cool our building with the solar on site. And that is as well possible with the Passivhaus approach, because the load that we are requiring for cooling is so small that we actually can achieve it with our little solar system on the roof. So, and then everybody's happy. Then from a financial thing that we always have to look at, this is the cash in hand. If you're running a business, you know exactly what I'm talking about. You can have a profitable business, but you have no cash on hand. Only cash is king. That's what we are reflecting here. And as a client, the additional financial burden in the first year for Passivhaus is a coffee a day. That's all what it costs you, a coffee a day, the $4.73. After 10 years, it's 7-Eleven coffee. And then after 19 to 20 years, we're coming to the break-even point. And then after 30 years, when the loan is paid off, you're getting a free lunch every single day because you invested in efficiency, the loan is paid off, and now you're not having this running costs any longer. And with this, we are having our free lunch every single day. This is not considering yet the benefits of green loans. So we can get green loans and lower interest rates. And with the lower interest rate, we're having a higher borrowing capacity, and our monthly would be actually lower than actually if you would buy a build conventional. So sometimes we're coming actually to that point already that you have a benefit from day one if we are able to get green loans with a good reduction in our interest rate. And as well, projects that have fallen through before might be able to get through if you're going for Passivhaus, because with a lower interest rate, you're having a higher borrowing capacity. And with the higher borrowing capacity, you might be able to finance even the Passivhaus, because that lower interest rate is not just for the Passivhaus components, it's for the whole build. And by that, you're able to have a benefit. But that's now economics. I have a whole course on that. That is 3 hours explaining how that actually works on our website. So let's look at Passivhaus in Australia. Passivhaus started over 10 years ago in South Australia, where they built in a bushfire zone, and it was a concrete block building. So we can build with concrete blocks, Passivhaus, no problem. Then the first Enafit a retrofit project was as well in 2013, and that was in Victoria. There was a timber structure, and then the first apartment block built was 2007. A little bit later, that was in New South Wales, and that was a concrete construction, conventional. Then I forgot that the update. The first university building that has been built was again in Victoria, built in steel, and then the first major development was as well in Victoria, and that I don't know what construction method they used. It's not 50 certified passive houses, it's now above 100. The more important part is that we achieved passive house for less than 2,500 square meter to build. That's not the additional cost, that's the whole building cost, the square meter cost for building a building. And we have achieved that multiple times in Australia already. So passive house does not need to be expensive. It's ideal for social housing and affordable housing. So perfect for government projects, because the biggest threat for people that need social housing and affordable housing is that their running costs of their home is already so high that they can't have a proper life. So if you're now able to give them a house that doesn't need so much running cost, they can afford better food, they can afford education, and by that their lifestyle will be far, far better, and hopefully as well able to contribute more to society because of a better living situation. However, it doesn't need to be. We can as well build crazy. Here the John Ward Architects, located in Melbourne, built between 2015 and 2019, 670 square meter over 3 levels. It was winning, it's a passive house and a living building challenge rating. And this building, was a few millions to build. I heard rumors that it was, I think, $8 million. So passive house can be as well expensive. Passive house is not limiting your design, it's your budget. Keep that in mind. Like passive house can be really affordable and cheap and cost effective, but you can design everything to the passive house standard. The impact of size, shape, and compactness. So here we're having our spa home. This is the home that we're modeling in our Passive House Designer course. And when that's a 125 square meter house, if you're building it in low quality, the additional cost is 15%, medium quality, then it's 8%, and high quality at $7,500, it's 5%. If you see the relation between the 2.5 and the 7.5, you see that this is 3 times the amount, and this is a third of the 15, because the passive house components are the same. That doesn't matter if it's a high end or low or medium, because we are not putting, instead of a high performing membrane for air tightness, a golden sheet in there. So no problem. As higher end the building is, as more cost effective it becomes, and especially commercial, because the ratio between building envelope and usable space is in such a benefit that it's super, super cost effective to go down the passive house route. Often in a percentage less than 1% or around 1%. So commercial works really well. So does passive house limit building methods and design? No, it does not. Like we have already seen, we can build in steel, we can be in straw bale, we can build in concrete, and we can build in timber. These are all passive houses. Passive house is not limited in the building methods that we use. It's a performance standard and not a material standard. So you decide what you use. So if you, for example, say you need an R value of 4.5, then you can use an EPS of 0.35 meters, so 135 millimeters, or you can use fiberglass with 180 millimeters of fiberglass, or you can use a timber, so CLT, then you would need 0.5 meter thickness, or you go for brick. Now we're at 4.5 meter thickness of a brick wall. You're not getting so much out of your lot any longer. Or you use concrete, reinforced concrete, then we're at 9 meter, or you use steel, then you need 225 meters of a steel thickness to achieve that R value of 4.5. Obviously makes no sense, and you would have a pretty far way to walk from your front door into the building if it's 225 meters, but you decide what material you use. We are not saying the one is better than the other. You use what is right for you, and it's not limiting design. even the Sagrada Familia in Barcelona could be a passive house if we would want to do it. Obviously, they're building now over 100 years on it already, and making a passive house would add a few years more, obviously, but theoretically it would be possible. We can say that that passive house can cost up to 20% more. However, we see that regularly architectural features cost 30% more. So the passive house components to make the building to perform and you have a comfortable life is far cheaper than your architectural components, like your glazed handrails or your designer glass top that you're only using once a year, while you could get a really high performing building for far less than the architectural features. And as well, you can only do that passive house stuff when we are building or when we are doing the retrofit. Architectural features can as well be updated in the future. So if you want to have your designer kitchen, maybe go first for an IKEA kitchen and then in 10 years upgrade it to your designer kitchen. And by that, you can still afford your passive house. So how energy efficient is a passive house? So if you're looking back to the time when we still had light bulbs like this, 4 60-watt light bulbs would be enough for 24 square meter of a living space to heat that on the coldest day of that location, or a really small radiator, 8 tea lights, a hair dryer on lowest level, or supply air heating, what is possible in a passive house. And that's the reason why they put that 10 watts in place. In my opinion, we don't need that 10 watts because we're doing it anyway with an air conditioning system. So we could have a higher load, but the demand is more the one, because the demand is the things that we are actually paying for. But maybe going a bit too deep here already on what passive house is. Then if you're looking now to our 10 watts per square meter, and we are saying we have a 150 square meter home, then a 1.5 kilowatt system would be enough. These really small baby splits that we have, they're normally already 2 kilowatt or even 3 kilowatt per unit. That means one of that units is sufficient from a load perspective. I mean, it makes no sense to have only one outlet, but theoretically we could condition our passive house with just a baby split if it's 150 square meter. How to design your cooling is something we cover in our courses, but from a theory that would work. So if you're now, for example, looking to Melbourne, where we have the lowest temperature of minus 2.5, then we want to achieve our 20 to 25 degrees. To achieve that, we would need a thickness of insulation of about 140 millimeters. And then we need a baby split of 1.5 kilowatt hours for our 150 square meter home. If you're now going to an extreme, the Charlotte Pass in New South Wales, where the temperature goes down to minus 23 degrees, we want to achieve again our temperature between 20 and 25 degrees, but now we need thermal insulation of 340 millimeters because we are protecting against a higher thermal difference. And that's the reason we need a thicker insulation. That's like you're putting more layers of clothes on, but it's actually getting colder. And that's what we're doing here as well. And now we need, again, just a baby split of 1.5 kilowatt hours for 150 square meter home. So we can use exactly the same building services in that location because we designed it that it is efficient as a passive house and all they can work with the same building system. If you now go to Western Australia, the hottest place where the temperature of 50.7 was recorded in 2022, there we again want to achieve the temperature between 20 and 25 degrees. And now to achieve that, we need 250 millimeters of thermal insulation. Now the thermal insulation is actually protecting us against the heat, not the cold. And here again, our baby split of 1.5 kilowatt hours for cooling is efficient for our 150 square meter home. So that's how it works. Simple, easy, straightforward. And that's what the beauty of a passive house is. If you're having a house designed that is, you spend a lot of time on designing, and now you want to build that house in multiple locations, the only thing you have to change is your thermal envelope performance with the thickness of your thermal insulation, maybe the glazing of your windows, and that's all you need to change. The rest of the building can stay the same. with the same systems. So especially if you're going down the prefabrication route and modular construction, this is such a huge benefit because you don't need to change your systems. You could buy the same baby split system, the same hot water systems, everything the same in quantity, and then actually use that. And it doesn't matter where you build because the performance will be always the same. Yeah, so that's a huge advantage as well of Passivhaus. So now real world example that is now going to more to the builder side. What is the benefit of Passivhaus? So here, cost savings. I know from builders in Europe that report that after normally 7 years, they can deliver Passivhaus for 10% cheaper than conventional buildings. We see that more and more, like we see it in residential, so freestanding houses. We see it in whole apartment blocks, and we see it on really big European projects where passive houses are winning the tendering process that is really rigorous in Europe, where the cheapest solution needs to be taken. And often passive houses win this tendering process, not because they're passive houses, but because they're cheaper. The reason for that is, okay, first, long-term benefits is through improved processes, we reduce waste. So we have less waste. With this, we need less material. With this, we're saving on the material side and having a smaller impact on the environment. And then by efficient through standardization, we streamlining workflows, and with this we are able to reduce mainly labor costs on that. So now from a performance perspective, this is now looking to the client's benefit again. That's again our spa home that I've modeled and looked at how that actually works. We said we're having a saving of $1,396 a year of energy savings of that house for to some extent domestic hot water, but then mainly conditioning. This is what we can achieve. The energy costs are rising by 4.7%. And the additional cost for Passivhaus is just under $400 per square meter. Again, that's the same table. And this house would cost additionally $48,000 if we build it like this. However, if it is a developer that is building the same house over and over again, I spoke with a guy, he said he's able to push that 48,000 below 20,000 additional costs if they would go into developing like something like 20 houses in one go, because the architecture costs and the modeling is strongly reduced and they can buy material far cheaper. And by that, they said, yeah, the additional cost is 20,000. Yeah, so that's where it goes. So we have a lot of benefits here as well. Then, like already mentioned, affordability of passive house is possible. We had already multiple passive houses for less than $2,500 achieved. We have achieved it in Western Australia and Victoria and Canberra, at least. There might be more places now, and affordable excellence is possible. Combined energy efficiency with affordability, we can achieve that with Passivhaus. For example, here this Acuna house, Carlos Acuna in WA, where they achieved that. Then prefabrication efficiency. So Passivhaus works extremely well with prefab because Passivhaus is not just a philosophy and an energy efficiency standard. It is as well a process of walking through a building. Yeah, so entire houses can be prefabricated in just 3 days. That's what we have achieved already. We're getting the plans, we start production. 3 days later, the house panels are standing in the factory. This is possible. By this, we're reducing labor costs and we're having faster project times. So we're saving for the client the double cost of renting and paying that building project. And we're saving as well on labor costs for the builder. And by that, we can actually reduce cost. And then factor control environment creates a highly exactness and repetition as well for the whole process. And with this, we're able to save as well energy again. Now back to the client. The clients have then improved well-being. I know clients that have less sinus affection and allergies and asthma. Then the indoor air quality is far higher, especially during bushfire. So we can filter out the bushfire smoke and pollen for people that are having like hay fever or so. So we can as well help these people, like the client here down in Denmark. So this is as well an advantage. Another one on the builder side is that we're anyway creating a digital twin for the performance already. And this digital twin is something that we can then use in the prefabrication process. And by that, again, Passivhaus is able to work hand in hand with prefabrication, digital twin, and then automation of processes in that process. So when we are now looking at our Passivhaus Tradesperson course that we're having, it's far more than just a course. It's the foundation for high-performing buildings, like our students that are here in the chat, like and it's future-proofing for builders. You're staying ahead of regulations, so you don't need to change your detailing and execution the whole time because you are already outperforming your performance. So you're having a far less changes in your building company because you're staying ahead of regulation changes and you don't have to change it every few years. Perfect prefabrication, essential for building consistent prefabrication is like passive houses need to be already really exact. And if you're going down the prefabrication route, you need to get your detailing right so that you're not going down the rabbit hole that you're developing now something, spending a lot of money on it. And then a few years later, you're realizing, wait a second, my whole detailing and philosophy of building is wrong. That's the reason you really, if you want to go down the prefabrication route, you need to do this course to understand how the buildings of the futures will be built, not necessarily because of the Passivhaus qualification you're gaining, but because of the knowledge you're gaining that is needed as the foundation for future-proof buildings. And then we're having prefabrication success only with precision. And this is what Passivhaus is already asking for, that precision, and that helps already. Yeah, this is now one of our practical courses where we're showing where the layer of coding is on the window. That's that picture showing. Then in the tradie course, we're showing really clear solutions like we can see here. We're having here our timber frame solution, the Californian corner, and explaining why the conventional is not working because we are not putting thermal insulation in that corner where we already have a thermal bridge. And now with having no insulation in there, we have far worse situations there. And that's the reason we are showing that on a really simple way. Then all our units are brought down to 20 minutes. So it's really handy for the busy schedule because you can choose when you do these units on yourself. And then we have a really practical approach how we teach everything and hands-on understanding with exercises, with questions and all the bits and pieces that help you to deepen the understanding and put it into reality. Adaptable knowledge, you can use that knowledge to build anywhere in the world in any common building methods in any climate zone. So we are teaching it in a way that we show you how to design a timber frame from the hottest climate to the coldest climate, how to do that with concrete construction, with masonry, and as well alternatives like SIPs or straw bale construction. We as well having a glimpse of that in there. So the learned is not just for Passivhaus, it's for any project that you will touch afterwards will be impacted by that beneficially because you learned that and you're implying that. The certification is internationally recognized. So you're gaining that knowledge. That's what you really want. But additionally, you're getting as well your internationally recognized certification that helps as well to find jobs because you will be listed on a list of professionals if you want to, so they can find you and reach out to you. And it opens doors to opportunities and shows your credibility in the industry. And normally people that value quality building and energy efficient buildings are normally more enjoyable clients to have. That's what I can say here. Cool. So that was our webinar as a short overview of what's happening. Any questions here? Were there questions coming up or anything in there?
Not in the chat, Daniel.
Not in the chat. Online, Nala, did you have any questions coming up?
None so far, Daniel.
None so far, cool. So any questions here right now? So this was like a really short introduction in the whole thing again, flying through it. Maybe you were able to take a few things out of there with especially designing a building so that you can cool on site. I think that's something that may have not been fully understood yet, or the connection between prefabrication and passive house and how they work hand in hand, and as well the opportunity to actually be at the end more cost effective than conventional building after the team is adapted to that better building methods. Then we can achieve that. But it normally, so what I've seen is normally it takes about 7 years of applying it, staying on top of it, and then we're coming to that results. And I'm sure we can achieve that as well here in Australia. Cool. Then thank you, everybody. It was great having you. Thank you. Jerry, or you have something to ask? Or was that just a thank you because you're muted? No, that's Jesse. Can I unmute you? Jerry, there we are. Still mute.
Yeah.
Okay, cool.
Daniel, I was interested in your comment about people installing very expensive kitchens and not giving the same regard to the building fabric.
Mm-hmm.
And statistically in Australia, we change our kitchens every 15 years and we pull out our bathrooms every 15 years. It stays for the life of the building. And how do we actually get that across to homeowners and architects and all the rest? It's always been my challenge.
Yeah, it's the emotional attachment. It's like it's easier to sell a granite kitchen countertop than itchy fiberglass in your wall. I think, like when we look to the building to the car industry, we are obviously seeing similar things. Like we have obviously in the car industry things that are definitely beneficial, like your electrical steering, that you have that steering support. And obviously when you had an old manual car where you really had to move the steering wheel, it was a nightmare. And there you see the benefit. And that I think is similar like to a kitchen or something. But nowadays we as well having airbags everywhere. But the airbags, I don't see a benefit in that. Like I don't experience that benefit. So it's a safety perspective that comes into play, but I think nobody would buy a car nowadays without airbags. It's just expected to be in there, and people would say, hey, there's no airbags in it, why? Yeah, so I think we need to find a way how to explain that we need that as a safety for us in the buildings to have this better thermal performance, especially in a heat wave. Yeah, so that survival during a heat wave, having a solar system on the roof that is able to cool the house down while the power grid is down. Because this is when it will happen. When is the power grid down? When you have a massive storm going through the region, or when we have an extremely challenging demand on the grid, and then the grid is just overpowered and then it fails as well. And that's exactly when everybody's switching on the air conditioning system. So we want to have systems that makes it possible to cool the building on site, and then cooling will be always free. Lifetime free cooling, never need to have to worry about it. And then if you have more, we can charge our electrical car, we can cool, like heat our domestic hot water. So I think it makes a lot of sense, especially in Australia. It is so economical to have a solar system on the roof. Again, solar systems we see more than passive house. Why? You can see if a solar system is installed. You know, it's like similar when somebody buys a new car in the street. Wait a few months, you see multiple new cars in the street. Yeah, if somebody puts a solar system on the roof, it's a social proof that somebody has it. Yeah, and then you see it more and more and more. But a passive house, it's just passive. It's not something you see. Yeah, and I think that's the problem as well. like I had multiple people doing the course because they came into a passive house in an extreme weather event, like in a hot day or a really cold day, and then they came in and had this extreme comfort experience. And then they say, I want to understand why that is, how that works. But how many times do we get the chance to get into a location like that? That's the reason I wanted to build Airbnbs around Australia in passive house so that people can experience it in holiday times. And then as well, architects and builders could actually give away a week free in a passive house or something like that to actually give them that experience and actually know it. Like if you physically experience it and have a physical understanding of the difference, then I think it happens. Yeah, and it's only the geeks that get it so far, and the people that are really like people that have kids that have really health problems. Then we see them going to passive house. So it's young, educated families, and then often the last home buyers that are building for their retirement, that are having already some health issues and considering it more as well. So that couple down in Denmark, he had asthma and often sinuses infection. All that was gone when they moved into the. It's not even a passive house; it's a high performance building, and I think people are often getting scared of the word passive house. Yeah, so like that passive house is so rigorous and so extreme and so much more. But after a while, when you've done it, it's super simple. You're putting another coat on. Like we're putting another layer in that is our air tightness layer. We're putting a bit more thermal insulation in there. We may have a bit better windows, but at the end, it's not rocket science. Yeah, it's the foundation of quality construction. And the word passive house is so badly chosen. Like passive is so bad. That word passive. And then house is misleading because everybody thinks it's only for houses. It's for any construction. And that's the reason why I'm moving to Smart Plus buildings. That's where the Smart Plus Academy is coming from. So Smart Plus buildings. And that has like a positive one. We have a smart building that is actually fulfilling your needs and wants, and then a plus building. So it's producing more energy than you actually need on site. So you can sell it to the grid. And now we're having a solution. Yeah, and that's as well with the cooling. We're producing more energy than we actually need so that we can actually succeed with the cooling. Yeah, so it is still a far way. And I personally haven't figured it out to bring it across yet, but give me another few months, hopefully not years, and we're hopefully improving our communication. So all what I do is now communicate to the outer world. All what I do is now trying to find out how can we bring it across. That's my focus. Yeah. Thank you for your question and my half an hour explanation. Any other thoughts or things to add? Cool. Then I say thank you to everybody. For the alumni, we have in 2 weeks, we have everybody, we have a Passive House social where we go especially on questions and bits and pieces. So we have a half an hour that is public for the whole community. And then we have after the half an hour where the alumni are in, and we can then go deeper into detailing and looking on plans and looking on bits and pieces to actually keep going with our learning and deepening of the understanding. So that's in 2 weeks as far as I know. If you want to learn more about the tradie or designer course next week, meet your teacher.
Designer course is next week. Yeah, so that's a welcome session. And the tradie one is 2 weeks after that. So yeah, if you want to know more about the tradie course or designer course, for those of you who don't know me, I'm the Passive House teacher at Smart Plus Academy. So yeah, you will meet me there or contact me. I'll share my email address. So if you have any questions in regards to the courses, then please email me. I'm more than happy to help you or have a chat if you're interested in joining.
Yes, well, like Julia is a bit more, Julia speaks a little bit slower and is a bit more structured in her approach. I'm more the inspiring and crazy dude that is going everywhere. So I'm more for the how to change the industry and where we are moving. And Julia is the structured, getting knowledge across person. So she is the perfect teacher to teach you there. Yeah. Okay, thank you. It's good to see some faces again. Dan, Milan, long time. And see you over the next few weeks in a few webinars and different places. See you then.
Everyone.
Bye.
Bye. See you all.